Okay, ready for the next part. We finished last time with an abstract view where I showed you how when you can take the physical world and in the physical world place a display which is connected to an alternate world generator that renders to the display, and then that provides the appropriate stimuli for whichever sense you're taking control of, and then this in some sense fools your brain into believing that you're in some alternate world, right. So, I drew that, and we had a very good question about by display do I mean visual display, and I said no, I mean not necessarily visual display, but including that, and it could be an audio display, could be a tactile display, could be one of many different kinds of displays. So, I want to talk about displays and rendering. And remember, this is just a bird's eye view. I'm just giving you a high level overview. In the rest of this course in the next 2 weeks we're going to go into more details on these things. I just wanted you to be able to see everything in one shot. So, that's what this lecture will be, the rest of the bird's eye view. So, let's think about the audio part and hearing, right. So, audio and hearing. So, the display is most commonly called a speaker, right. So, we have a speaker, right, letting out some sound, right. So, that's perfectly fine. When we're trying to use a word that's common for all the senses, we'll call it a display. And rendering produces the appropriate signal that then gets converted into sound pressure waves by the speaker, which is the display in this case, right. So, rendering produces the appropriate, I don't know whether to call it the audio signal or the sound pressure waves depending on where you're at exactly, but ultimately produces the signal, let's say to convert to air pressure waves, I should say. Okay, I'm going to erase this announcement for a minute. Again, it's very important to connect on Piazza for the class forum. So, follow this link and register for that. I want to think about two different kinds of systems here for audio, and then we'll talk about the visual part. So, compare two audio systems that you should be familiar with. So, in one of them, suppose you're sitting in a movie theater, right. So, I will draw some wonderful art here. So, you're sitting in a movie theater and you have your ears. You can turn your head however you like, but you generally don't leave your seat, let's say. And then all around there are speakers of some kind which are audio displays. Let me put a bunch around here. And in fact, if I put it like this, I could put labels on these, I guess, like there's a front left and front right and front center. Put a couple of subwoofers here, some middle left and right speakers, some rear left and right speakers, and then you have what's called 7.2 surround sound, right. So, one particular technology standard by putting enough speakers around. Let's compare that to wearing earphones. You may also call them headphones, but I'm using the term ear to make it very clear that we're just talking about the audio part, because this is kind of like a headphone too when you wear a head mounted display for the vision part. So, you have earphones. So, now you're still there with the of your ears, but you have some kind of I'll exaggerate the size of these. These will look like earphones from the 1970s, and or it may be a very expensive pair, let's say, and you have this connected together somehow. So now when you turn your head, the earphones follow your ears directly, and when you're here and you turn your head, the location of these displays is changing relative to your head, right? Did you ever think about that difference? Right? It's happening all the time for you, right? So something fundamentally different is going on between these two, and people do not seem to make a big deal out of it, right? Also pay attention to the fact that here in 7:2 surround, when you're at the theater, the display is far away. Here the display is very close. Right. So now I want to think about virtual reality systems for the visual part. We can argue about whether or not this is virtual reality for audio, but hey, it's just a different sense. So let me think about it for the visual part. I will reuse this space here. And so I told you about two different kinds of virtual reality systems in the last lecture. One of them was a cave type system, and the other one is a head mounted display. I think from this drawing over here it should be pretty obvious which would be which if I want to make a perfect correspondence. So let's suppose again I'm here. I guess I'm not wearing earphones in this case. I'm just have my eyes looking around, and I guess I'm not emphasizing the audio part, and I have some kind of projection systems here that are projecting onto screens all around. And I guess I don't have to draw all of these, but there's at least 3 of them. You could put 4 or 6. You could have projectors all around. You could be inside of a cube if you want. So this would be a cave system. Again, this should, in terms of the way it's working on your body, should be very similar to 7:2 surround, correct? Right? And again, the displays could be very far away. Now there's something more that could go on here, which is do I want to change the viewpoint based on where my head is? Right? So it could be that as I move around I want to change what's shown on these screens to be dependent on where your head is and where you're looking. That you would need for stereo, or just simply to change the perspective so that when things are very close it moves so that it, you know, you walk up to something and it moves appropriately. So so you may need to do that. Interestingly enough, I guess you could do the same thing in the theater, right? You could have the audio custom tuned just for you, so that if you decide to walk around in the theater, the audio changes that goes into the displays, right? Has anyone ever done that for you in the theater? No, right? But it could, right? So it's very interesting to compare these two. The other one, we're making a perfect comparison here, would be what's called a head mounted display. I'll just write HMD, head mounted display. Another word for that is iPhones, right? Turns out Jaron Lanier used that term for his product with these goggles back in the 1980s. So it's a different kind of iPhone than the one you know today, right? So but it makes perfect sense if we compare these two. We have earphones here, iPhones here. They're both different kinds of headphones, and I guess you could call both of them a head mounted display, right? Even if you put on these earphones here, you could call that a head mounted display where the display corresponds to speakers, right? All right. So I guess in this case I'll draw my head again, and of course when you wear a head mounted display you have the usual problem of there's a brick covering your face, right? Right, so you look a little bit ridiculous to everyone else because you appear to be wearing some kind of blindfold, right? So so that's how it looks in the head mounted display case, but you know, this looks slightly ridiculous, but we've become accustomed to that. You can't hear what's going on around you. Here you cannot see what's going on around you if you're wearing a virtual reality headset that's not designed for augmented reality. If it were designed for augmented reality, then it might look just like a pair of glasses, right? And then it has extra information appearing on it. All right. So what's interesting is to make this work, Do you need to track your head to figure out which way you're looking, to figure out what to put on the display? If you choose not to, then whatever you see is going to look like it's fixed to your head, right? So if you want to be sitting in a virtual movie theater watching a virtual movie, it will look like the entire movie theater is glued to your head, right? It moves effortlessly, of course, because the physics is different there, but that's how you will perceive it. Like as if everything moves exactly with your head. Interestingly, that's exactly what's happening with headphones as well, right? Because if you turn your head while wearing earphones, if you turn your head while wearing earphones, you should perceive it as everything moving exactly with your ears. Why doesn't anybody care about this, right? We've been using earphones for a very long time. Nobody worries about head tracking here yet. They are now that head tracking quite easy to do. But here everyone became obsessed with head tracking. It became required to make it work. Anybody know why? Strange, isn't it? We're just comparing these two senses. Nobody cared about head tracking on this side, on the audio part. Why does it seem to be necessary on the visual side? I'm sorry? Direction. The direction. Well, but it's the same in both cases. So direction. Let's think about this, I guess. So I mean ultimately the direction that the sound or the visual signal is coming from is important. I think in the case of audio, especially when you're wearing headphones listening to, let's say, recorded music, where does it sound like the music's coming from? Sort of like inside of your head is what most people say. I've talked to some audio engineers, and it sounds in most cases when you put on headphones listening to music, close your eyes, imagine where the band is at playing the music, for example, it sounds like it's inside your head, and we seem perfectly comfortable with that. So when you're rotating your head, it doesn't seem to make much of a difference. It's still inside of your head, and we've become accustomed to that. The vision sense is much more detailed, right? We have an entire picture of what's going on around us. It's not simply signal processing of a single signal with higher frequency going into our ear canals. It's you know, through the power of optics, other things we'll get into, you see an entire image, and there's so much more detail there that you notice if you turn your head and everything's moving with you versus it looks stationary just like it does in the real world. That makes a very big difference. So I think a lot of it's just the level of fidelity with regard to the visual sense in comparison to the audio sense, and the fact that in audio we've grown accustomed to just hearing the sound source inside of our head. If you present left and right speakers, you will perceive it as being interpolated in between, right, the sound. So it just ends up interpolating right in between, and it feels like the sound is in your head. And we've just grown accustomed to that. There are tricks you can do to make it sound like it's coming from the outside, and then you need to do head tracking and some other tricks, things like head related transfer functions. I hope to have one lecture where we cover that. I expect to, and so we can get into some of those details. So you can take some of these kinds of concepts that came up in virtual reality for vision and apply them back in audio, and now thanks to the latest head tracking technology that's easily available, it's quite reasonable to do this. So even just on the earphone side, you can improve this technology considerably. So that's very exciting, I think. All right, let's also think about, I mentioned this already, but think about the distance of the display from the sense organ, right? So here the display is far away. Those of you sitting here in the audience, you can see the screen. It doesn't have anything interesting on it now, but you can see the screen, and it's far away from you, right? If you wear a head mounted display, say iPhones, then the display is very, very close. In fact, it's so close that we need to use some lenses to put so that your eyes can still nevertheless focus on this screen that's very close. So we're kind of helping. Your eyes don't have enough optical power to focus on something very, very close, even if you're a small child. So the lenses provide some help in that, and will make the screen appear like it's infinitely far away, and filling your field of view completely. So it ends up being presented very, very close. Well, what happens? I guess if the display is far away, then it needs more power, right? It needs to be larger, needs more power. If I want to you know, think about the size of a movie screen at the theater. I guess they use projection technology so that they don't have to make a gigantic screen, right, out of say OLEDs or LEDs or LCDs or something like that. So they don't have to do that thanks to projection technology, but it has to be enormous, right? It has to be very loud in the theater because the audio rendering, the speakers are far away. If you have earphones and iPhones, then it doesn't have to be as loud and it doesn't have to be as large. It can be very small. So there's some engineering advantages, but to make it work you may have to do more work on the head tracking parts, right. The head tracking may become necessary. So there's some more engineering work to do, but as the technology improves it can lead to greater portability and lower cost, and generally the amount of signal or power that you need to generate of course is going to be less the closer it is to your actual sense organ, correct. This may cause you to want to go further. Why even bother with putting some display very close to your face? Why not beam information directly onto your retina, right, the light information directly on your retina. So there are retinal displays that do exactly that. You're probably wondering why not go one step further. Why don't we just cut out your eyeball altogether and just directly provide stimulation to your optic nerve, right. If we can match it exactly that ought to work, right. Again there's going to be a lot of to make that work there's going to be a lot of engineering challenges to match it perfectly. We don't really understand exactly what goes over the optical nerve, but if we did and we could reproduce exactly that signal, that would be like having an HDMI connector directly to the visual part of your brain. You just feed in the signal and everything's fine. Certainly it's going to require head tracking to make that work and very low latency and lots of other things, and unfortunately it would be sort of a one-way trip, right. We could maybe wire you like that, but then it's hard to get you back to normal again once you're done. So you'll have to be a permanent cyborg at that point. So it's interesting to think about, right. Where exactly is the place where you want to interrupt the stimulus and present the display. So try to get closer to make it more portable and lower energy is needed, but the closer you get the harder it gets engineering wise to achieve, the more tricks you may have to do. All right, I want to say a little bit more about hardware, and in my bird's eye view I have three components. I'm going to talk a little bit about hardware, which I've already been doing, and then I want to talk a little bit about software, and then a little bit about perceptual psychology, sensation and perception, and those will be the three components of my bird's eye view. So just continuing on the hardware, I just want to say a few things, and we'll go into much more detail on these things later.